Yeah. This video is part of playlist Integral B Nepal past year problems. So in this video, we are here with some easy past year problems from Integral B Nepal, and you can find medium and hard level problems in the playlist too. Yeah, let's begin. For this problem, we will use integration by parts. We can have this log x as u and this as b, and when differentiate it, it gets into similar form. So we have log x times x to the power 5 by 2 by 5 by 2 minus integral of 1 by x as derivative of log x, and then x to the power 5 by 2 by 5 by 2 and dx. Now after this we have 2 by 5 log x to the power 5 by 2 minus 2 by 5, and then integral of x to the power 3 by 2, so that's again x to the power 5 by 2 by 5 by 2 plus c, so that's the answer. 2 by 5 log x to the power 5 by 2 minus 405 x to the power c. Yeah, so the next one. For this one, we can just let x square as y, and then here we will have x square times x dx. So if y equals to x square, we can have dy as 2x dx. So dy by 2 equals to x dx. Now we have here y dy by 2 times y plus 1 whole square. We can just take 1 by 2 out, so that gives us y plus 1 minus 1 by y plus 1 square dy, and then 1 by 2 integral from y by y plus 1 minus 1 by y plus 1 square dy. So now taking integral of this function is quite easier. So 1 by 2, it's ln of y plus 1, and y is x square, so ln of x square plus 1, and then plus 1 by x square plus 1 plus c. So that was it. Yeah, so next one. For this one, we can just see that if since here is x square plus 2, we try to make it x to the power 4 minus 4, and that would simplify us a lot. X to the power 4 minus 4 plus 5 by x square plus 2 dx. So this goes into integral of x square minus 2 plus 5 by x square plus 2 dx. So up to that we have x cubed by 3 minus 2x plus 5 by root 2 tan inverse x by root 2 plus c. Okay, so that's the answer. Yeah. For this one, we can see that the graph of f(x), we would want to check the graph of f of x first. If we check the graph of x and f of x, we would find that the graph is something like semicircle. It's actually semicircle. Yeah. And how do I know this? Just if we let y as root under 4 minus x square, we can change it to y square plus x square equals to 4 or 2 square, so that's equation of circle with radius 2. Yeah, but since here is positive sign, we just keep a semicircle, and the integral is equivalent to area, so and the area is pi times 2 square by 2, so that's 2 pi. Okay, so go to the next one. Yeah, for this problem we can let y equals to cos x, and then we have here sine square x, which is 1 minus x square, and sine x dx, which is minus dy. Okay, and after that we have here 1 to 0, 1 minus y square minus dy by y minus 1, and then we can just use this minus sign to change it into y square minus 1 by y minus 1 dy. Now you can use reflection on the limits of integral, so that becomes 0 to 1, y plus 1 or dy. And after this we have negative of y square by 2 plus y from 0 to 1, so that's negative of 3 by 2, which is the answer. Going to next one. For this we can use beta gamma function. Let y equals to 2t, then dy equals to 2 times dt, and we have 0 to pi by 2 sine a cube y cos y and dy by 2, and then we have 1 by 2 integral from 0 to pi by 2 sine cube y cos y dy. Now we know that integral from 0 to pi by 2 sine to the power my cos to the power ny dy is equals to beta of m plus 1 by 2 n plus 1 by 2 by 2 for power m and n. So this is the formula. Now for power 3 and 1 we have 1 by 2, beta of 4 by 2 is 2, 2 by 2 is 1 by 2. Now for beta function we have this formula as gamma 2 gamma 1 by gamma 2 plus 1. Yeah, if we evaluate this we get 1 by 4, gamma 2 is 1, gamma 1 is 1 by gamma 3 is 2, so that's 1 by 8. Yeah, let's go to the next one. For this one we can do something like this. We can first write cosec is for x as a product of cosec square x and cosec square x, and then one cosec square x can be changed into 1 plus cot square x, and the other as it is minus cosec, and we make here a minus so that it's the derivative of cot x. Yeah? Now we can just let cot x as y, and then this will be dy. Okay, so it's minus of 1 plus y square times dy, so it's minus of y plus y cube by 3 plus c, and we can just replace y by cot x. We get the answer minus cot x minus cot cube x 3y plus c. For this next problem we can just let root x as y. Okay, and then we have y square equals to x, so 2y dy equals to dx. Now we have y, dx is 2y dy by 1 plus y square, and then we can just take 2 out, and we can make something like y square plus 1 minus y 1 by y plus y square dy, and this will be 2 times 1 minus 1 by 1 plus y square dy, so that's y minus tan inverse y plus c, and y is root x, so that's 2 times root x minus tan inverse root x plus c. So this is the answer. You can check. Yeah, let's go to the next one. For this one, just check that if we have y equals to log x, tan x dx is just dy, so our answer is ln of y, and y is log cos x, so ln of cos x plus c. It's just integral that can be calculated in mind itself. ln of cos x. Wait, I was overconfident or somewhat. If we have yeah, I was overconfident, I guess. So if we have y equals to log cos x, and then dy equals to 1 by cos x dot minus sin x actually. It can happen. So it's minus dy, not just the tan x dx is minus dy, not just dy. So if it's minus dy, we will get minus out, so it's minus ln cos x plus c. Now for this one we can have minus of minus 1 by e to the power x minus 1 dx. Okay, and after that we can add and subtract e to the power x. Yeah, and then we have negative of here 1 minus e to the power x by e to the power x minus 1 dx. Is it? Yes, it is. And then we have here negative of the integral of 1 is x minus here. If we let if we let the denominator as y, we get e to the power x dx as dy. So this is ln of e to the power x minus 1 plus c. And so we just multiply by minus sign, ln of e to the power x minus 1 minus x plus c as our answer. Yes, let's go to the next one. Yeah, for this we can use beta gamma function. So that's beta of 5 plus 1 by 2, that's 3, and cos has power 0, so 0 plus 1 by 2, that's 1 by 2 by 2. And then this is gamma 3, gamma 1 by 2 by gamma of 3 plus 1 by 2, that is 6, 7 by 2. We also have 1 by 2 over here. Let me just drink some water before I continue. Yeah. Now we have gamma of 3 is 2, gamma of 1 by 2 is root pi, and then we have gamma of 7 by 2 as 5 by 2 into 3 by 2 into 1 by 2 into root pi into 1 by 2 over here. So we can cancel these two out, and then we can have we can also cancel these two out. So it's 8 by 15. Is it? There it is. Let's go to the next one. For this, you can use some high school ideas. And this is just x plus 2 whole square plus 3 square. So we have the answer 1 by 3 tan inverse x plus 2 by 3 plus c, and that's the answer. Let's head on to the next one. Yeah, for this one I don't think we can use beta gamma functions since we don't have 0 to pi by 8, something like that. Yeah, we don't have this. Yeah, for this one we can just suppose sin x as y, and then we have dy equals to cos x dx. Yeah, this can help. And the limits will be from 1 by root 2 to 1, and we have 1 minus y square dy by y to the power 1 by 2. But now it's an easy question. And since we have y to the power minus 1 by 2 minus y to the power 3 by 2 dy. Now this is just y to the power 1 by 2 by 1 by 2 minus y to the power 5 by 2 by 5 by 2 from 1 by root 2 to 1. And now you can just find it yourself, or let me do it. 2 times this one is when we evaluate it to 1, so this is 1 minus 1 by 5. Okay, and when at this value it's 2 to the power minus 1 by 4 minus over here it's 2 to the power minus 5 by 4 by 5. Yeah, and now this is 2 times this one is 4 by 5. Is it? Yeah, it is. And then here we have so this one is 2 to the power minus 1 by 4 by 10. Yeah, and then we have 9 by 10 2 to the power minus 1 by 4. So this will be 8. Yeah, this will be 8 by 5 minus 9 by 5 2 to the power minus 1 by 4 plus c. Yeah, that's the answer. So next one, for this one we can just take out we can just take LCM, and then we have 9 minus x squared dx. Now you can again see that it's just the area of semicircle. Yeah, from minus 3 to 3. Minus 3 to 3. So we'll just find that it's 2 by 3 into pi 3 square by 2. So the answer is 3 pi. This was easier. Let's go to the next one. For this one, you can we'll first try to divide the denominator to the numerator. That will be sec x square tan x square times e to the power sec x square dx. Now you notice that if you just let y as e to the power sec x square, the derivative we get is also similar to this expression. So that's e to the power sec x square and then sec x square tan x square and then 2x dx. Yeah, so this expression is just dy by 2 is the given expression. Okay, so you can just write it as dy by 2. You can just write this expression as dy by 2. So that gives us answer as y by 2 plus c, and where y is e to the power sec x square. E to the power sec x square by 2 plus c is our answer. Yeah. Let's go to the next one. For this one, we can just let tan inverse x as y. So 0 to pi by 2, and then we have sine y dy, and minus cos y from 0 to pi by 2, so that 0 plus 1 is equals to 1. Next one. Let's go to the next one. For this one, we have we can just divide it. It's 3 minus 1 by 2, that's 5 by 2, plus 3 times x to the power 1 by 2, plus 4 times x to the power minus 1 by 2 dx. Now we'll just take integrations. It's x to the power 7 by 2 by 7 by 2 plus 3 times x to the power 3 by 2 by 3 by 2 plus 4x to the power 1 by 2 by 1 by 2 plus c. So that gives us 2 by 7 x to the power 7 by 2 plus this one is plus 2 x to the power 3 by 2 and then 8 x to the power 1 by 2 plus c. I guess that's the answer. 2 x to the power 3 by 2. That's the answer. So the next one. For this one, I guess we can just let y as root x. Since dy equals to 1 by 2 root x dx, and 2 dy will be 1 by root x dx. Yeah. So 1 by root x times dx will be just 2 dy by 1 plus y square. So that's 2 times tan inverse y, and y is root x plus c. So that's the answer. Let's go to the next one. Yeah, for this one we can just make some groupings. X square times x minus 1, and here plus 1 times x minus 1 by x minus 1 dx. So now when we divide it, we get x square plus 1 dx. So that's x cubed by 3 plus x plus c. And that's the answer. So the next one. For this one, if we just let y equals to pi times e to the power x, our dy equals to pi times e to the power x times ln of pi, then e to the power x, then e to the power x, then dx. So our dy by ln of pi is just this expression. This expression is just dy by ln of pi, isn't it? You can see from here. So the integral will be y by ln of pi plus c, and our y is just pi times e to the power x by ln pi plus. So that's the answer. You can just take here. pi by 2. Yeah. For this one, we can just distribute it. So that's x to the power 1 by 2 minus x to the power 3 by 2 dx. So this should be x to the power 3 by 2 by 3 by 2 minus x to the power 5 by 2 by 5 by 2 plus c. It is quite simpler one. Yeah. So the next one, for this one, we can do something like this: sec square x, and tan square x is just sec square x minus 1, and then we have remaining sec x tan x over here. Yeah, so now that's if we just let sec x as y, this is y square minus 1 times dy. So the y to the power 4 is y to the power 5 by 5, y to the power 2 is y to the power 3 by 3 plus c, and y is just sec x. You can put that. Yeah. For this one, if you just let this as y, 1 by x dx is dy. Okay. So if y equals to 1 plus ln x, our dy equals to 1 by x dx. Yeah. So the answer will be ln of 1 plus ln x plus c. It was simple. Ln of 1 plus ln x plus c. Yeah. Good, next one. For this one, we would first try to make the substitution so that it simplifies. Yeah. And then we have minus a square to a square modulus of y cube times dy. Yeah. Now since y cube is an odd function, but modulus of y cube is an even function, we can say it has 2 times integral from 0 to a square, and then we have y cube dy. Now we can remove modulus since all the values here are positive itself. So this is 2 times y to the power 4 by 4 from 0 to a square. So that's 2 times a to the power 8 by 4. That is a to the power 8 by 2. That's the answer. But next one, for this one, I guess we can do something like they can just complete the square. Yeah, do this thing here, and yeah, now it's in the simpler form. It's 1 by x plus 1 plus 1 by x plus 1 to the power 3 dx. Now we can do it. It's ln of x plus 1, and then plus x plus 1 to the power minus 2 by minus 2 plus c. That is the answer. Ln of x plus 1 minus 1 by 2 x plus c. Yeah, that's the answer. Let's go to the next one. Yeah, for this one we have integral from 3 by 5 to the power x plus 4 by 5 to the power x dx. So we can just integrate it, it's easier. So it's 3 by 5 to the power x by ln of 3 by 5, since it's the integral formula for integral of a to the power x. Yeah. And that's 4 by 5 to the power x by ln of 4 by 5 plus c. So that is it. For the next one, for this one, you can just let y equals to root x, and it will do its work. Y square equals to x, so 2y dy equals to dx. Now after this, we have dx as 2y dy, and here y square minus y, so the y cancels out, so it's 2 by y minus 1 dy. So we get the answer 2 times ln of y minus 1 plus c, and y is just root x, so 2 times ln of root x minus 1 plus c as our answer. Let's get on to the next one. For this one, it's just negative cos x, yeah, dx. So integral negative cos x is negative sin x from 0 to pi, but it's 0. Let's go to the next one. But let me just drink something. But this, we can use the property of logs, that log of AB is equals to log A plus log B. And then we have x ln x. Now you can let y as ln x. Okay, if you let y as ln x, we will have ln 2 plus y by y, and then 1 by x dx is just dy. And after that, it's a lot easier. It's ln 2 by y plus 1 and then dy. So now this one is ln 2 ln y plus y plus c, and y is just ln y. So it's ln 2 ln of ln y plus ln y, ln x, not y, ln x, and ln x plus c. So ln 2 ln x plus ln x plus c. Yeah. Let's put next one. For this one, you can use beta function. It's 0 to pi by 2 and sine of 1 by 2. Let's make it alpha. Alpha cos of 5 alpha d alpha. Yeah. Now if it's beta function, it's just 1 by 2 plus 1, that's 3 by 2. Gamma 3, sorry, beta 3 by 4, not closed, beta 3 by 4, comma 6, 3 by 2. And now that is 1 by 2, gamma 3 by 4, gamma 3 by gamma 15 by 4. Yeah, and for this one, 1 by 2 into gamma 3 by 4 into gamma 3 is just 2, and this one is just 11 by 4 into 7 by 4 into 3 by 4 into gamma 3 by 4. Yeah. Okay, so this to cancel out and 2 to cancel out. So this should be 64 over 21 times 11 is 231. This is the answer. Yeah. Now for this one, we can just use the property from trigonometry. It's 1 minus cos 2x plus 2b by 2 dx. So that will be 1 by 2 x minus sine 2ax plus 2b by 2a plus c. So that's the answer. It's in a bit different form, but it's again x by 2 minus sine of 2ax plus 2b by 4a plus c. We also had x by 2 minus sine 2ax plus 2b by 4a plus c. Same answer. Since this is b by 2a, it can be taken into constant. So for this one, we can just let this as y, and we get the answer. It's from 1 to 0 minus dy by 1 plus y square. And then we can just reflect the limits, tan inverse y, and if from 0 to 1, and that's just pi by 4. Okay, pi by 4. So next one. For this one, we can just let e to the power x square as y. E to the power x square as y, then dy will be e to the power x square times 2x dx. So dy by 2 equals to e to the power x square dot x dx. Yeah. So now the numerator is just dy by 2. And the denominator is just y square plus 1. So that's 1 by 2 tan inverse y. And now y is e to the power x square. E to the power x square plus c is the answer. 1 by 2 tan inverse e to the power x square plus c. Yeah. So go to next one. With this one, we can just change the sine into cos first. 1 plus cos of pi by 2 minus x, because now this can get reduced into some simpler forms. 0 to pi root under this is 2 cos square of pi by 4 minus x by 2 dx. So this is root 2 times 0 to pi cos of pi by 4 minus x by 2 dx. So now this will be root 2 times sine of pi by 4 minus x by 2 by minus 1 by 2 from 0 to pi, is it? Yeah, from 0 to pi, and then this will be minus 2 root 2, and when we have pi here, this will be sine of minus pi by, that is minus 1 by root 2. We have 0 here, that will be minus 1 by root 2 again. Yeah. So now we have minus 2 root 2 into minus root 2, so that is 4. And let's go to the next one. For this one, if we just let ln x as y, 1 by ln x dot 1 by x will be our dy. So our dy will be this and times dx. So our answer would be ln of ln x plus c. That's the answer. Let's go to the next one. For this one, for this problem, what we can do is we can just first try to divide the numerator. So that gives us sec square x plus sec x tan x dx. Now you can notice that this is just the derivative of e to the power x tan x. Yeah, this is just the derivative of e to the power x tan x. So the answer would be e to the power x tan x plus c. And we get that, sir. I'm busy, Excel. I'm busy right now. Okay. So, भाइ म एकछिन बिजी छु, अलि पछि कुरा गरौँला है. Now let's go to the next one. For this problem,
भाइ म अहिले काममा छु, अलि पछि कुरा गरौँला के. म अहिले काममा छु, 1 घण्टा पछि.
now in this
important काम छ के.
Okay, now for this problem, sorry for the disturbance, and now for this problem, what you can do is we can just make some changes here. Integral from 0 to 1, and then this will be negative of x minus 1 by x plus 1 dx. So this will be negative of 0 to 1, x plus 1 minus 2 by x plus 1 dx. So this will be negative of integral from 0 to 1, 1 minus 2 by x plus 1 dx. Yeah, then minus of x minus 2 ln of x plus 1 from 0 to 1. So that is negative of 1 minus 2 ln 2, and then minus 0 plus 2 times 0. So that's 2 ln 2 minus 1 is the answer. Yeah, let's go to the next one. For this one, we can just use integration by parts. So that gives us tan inverse x times x minus integration of 1 by 1 plus x square times x dx. So now after this, we have x tan inverse x minus 1 by 2 ln of 1 plus x square plus c. You can just let this as y, and then it will be dy by 2. So that does it. Yeah. So next one. For this problem, we can just let y equals to 1 minus x, and then we have dy equals to minus dx. Yeah, and minus of, so this will be 1 minus y, and this will be y to the power 2022. Okay, and then dy, the minus is here, and then after this we can do something like y to the power 2022 minus y to the power 2023 dy. So that should be y to the power 2024 by 2024 minus y to the power 2023 by 2023 plus c. And in place of y, just put 1 minus x, and that should be the answer. Yeah. Now for this next problem, just notice that the difference here are same. 3 and 5 difference of 2, 1 minus 1 difference of 2. So if we just take e to the power 4x as common in the numerator, we would get e to the power minus x plus e to the power x, which is exactly the same, that is the numerator, and then dx. So after this we have e to the power 4x dx, and then the answer will be e to the power 4x by 4 plus c. Yeah. And for this one, just let this as y, and the answer will be minus cos y from ln of 1 is 0 to ln 2. Okay, and then we have minus cos ln 2 plus 1 as the answer. Yeah. So the next one, for this one, what you can probably do is you can just check for the derivative that's in the form of product rule. So if you just see that, if you just have this as y, then dy equals to e to the power x sine of e to the power x plus e to the power x cos e to the power x times e to the power x. So this is exactly the same expression. So this is just dy, and its integral will be y plus c, and that is e to the power x sine of e to the power x plus c. Or you can also use integration by parts in this expression, and you will see that after getting this one, other will cancel out, and that's the answer. Or you can just notice the pattern over here. Yeah. And for this one, you can just use some high school maths, nothing more. Dx by x plus 1 whole square plus 2 square. So that's 1 by 2 tan inverse x plus 1 by 2 from minus 1 to 1. So that's 1 by 2 tan inverse 2 by 2 is 1 minus tan inverse 0. So tan inverse 1 pi by 4, and here's 1 by 2, so that's pi by 8. Yeah. So the next one, for this one, you can just let to the power x as y. So dy by ln 2 will be 2 to the power x dx. Yeah. With that, we have dy 1 by ln 2 by 1 plus x square, and now it's just tan inverse x. So 1 by ln 2 tan inverse y, where y is 2 to the power x plus c. That's the answer. Let's go to the next one. For this one, you can just use integration by parts. X sine of pi x by pi minus integral of 1 times sine pi x by pi. Okay, and after that we have x sine pi x by pi, and then it will be minus 1 by pi. Again, this its integral is minus cos pi x by pi. Yeah. So cos pi x by pi, and minus sign will make it plus, and the integral is from 0 to 1 by 2. Okay, so that should be 1 by 2 sin 90 is 1 by pi plus 0, and minus of 0 plus 1 by pi square. So that's 1 by 2 pi minus 1 by pi square. That's the answer. To make it in that form, we can just do pi minus 2 by 2 pi square. Yeah. Now for this one, we can do something like, we can just let sin u as y equals to sin u. So then we have 1 by 2 pi integral from 0 to pi, and this is y square 1 minus y square times dy. So now it's 1 by 2 pi y to the power 3 by 3 minus y to the power 5 by 5 from 0 to pi, and then we have 1 by 2 pi. This one is pi cube by 3. Wait. After we do sin u, its sine of 0 is 0, and here sine of pi is also 0. I didn't change the limits, so it's from 0 to 0, and that's just 0. We don't need to do anything. No, it's just 0 minus 0. doesn't make sense. That's 0. For the next one, for this one, we see that if we let this as y, this whole expression is just dy, so it's integral of sec square y dy. So there's tan y plus c, and y is just x e to the power x plus c. That's the answer. For this next question, we can just have something like 0 to 1 x square to 10 to 1 minus x square times x dx. Yeah. Now if we have this expression x square as y, that will give us 0 to 1 y root 1 minus, but that won't do us any good. So just have y equals to 1 minus x square, then 2y equals to minus 2x dx. Now this will do us some good, and the limits will be from 1 to 0, and this will be 1 minus y root y times, that will be dy by minus 2, and then minus will help us reflect the limits to 0 to 1, and then 1 by 2. We will have 1 by 2 minus y to the power 3 by 2 dy. And now we have 1 by 2 y to the power 3 by 2 by 3 by 2 minus y to the power 5 by 2 by 5 by 2 from 0 to 1. So now that's 1 by 3 minus 1 by 5, which is 2 by 15 as the answer. And so the next one, for this one, we can just let this expression as y, and we get this as dy. Yeah, so e to the power y is the answer, and then e to the power sin x cos x plus c. Let's go to the next one. For this one, what we might want to do is, we can just we can just do integration by parts. So that's x square sin x minus integral of 2x sin x plus integral of x sin x. Okay, dx. So now there's x square sin x minus integral of x sin x dx. Now we can again use the integration by parts, and that gives us x square sin x minus, this is x minus cos x, and then minus integral of 1 times minus cos x dx. Yeah, and then we have x square sine x. This should be x cos x, and this should be minus minus plus, and integral of minus cos x is again minus sine x plus c. So this is x square sine x plus x cos x minus sine x plus c, and we can just take here x square minus 1 sine x plus x cos x plus c. For the next problem, what we can do is we can just do something like, we'll first take the integration by parts for this function, and you will notice something. Yeah, let's do it. If we take it integral, this will be minus 1 by log x dot x minus integral of its derivative will be 1 by a log x square, and then 1 by x dot x dx. Okay. Yeah. So we are just taking the integral. This is just the integral of minus 1 by log x. This is just the integral of minus 1 by log x dx. Yeah. And so after this we have minus x by log x minus integral of 1 by log square x dx. So now if we take it to other side, we get integral of 1 by log square x minus 1 by log x dx. So this integral is equals to minus x by log x plus c. That's the answer. Yeah. For this next problem, we can just use some high school maths. 2 by 4, 2 to 4, and dx. This will be root under minus of x square minus 6x plus 8. Now this will be into from 2 to 4 dx by root under minus of x minus 3 whole square minus 1. So that will be from 2 to 4 dx by root under 1. Sorry, this is not x square. 1 minus x minus 3 whole square. So this is just a sine inverse formula. So we get sine inverse x by a from 2 to 4. So this is pi by 2 minus pi by 2. So overall we get just pi. Yeah. So the next one. For this one, what we can do is we can first just use the product formula from trigonometry. Yeah, that gives us 0 to pi by 4 sine of a plus b by sine of, okay, first let me write 1 by 2 so that it's, so first let me change it to the form of product, right? Now we have sine of a plus b, that's sine of 3x, and plus sine of a minus b, that's sine of minus x dx. Now it's 1 by 2 integral from 0 to pi by 4 sine 3x minus sine x dx. Now we can have 1 by 2, this is minus cos 3x by 3 minus cos x by minus 1 from 0 to pi by 4. Yeah. Now we have 1 by 2, this one. Now for evaluating this one, 3 pi by 4 is just 1 by root 2, yeah? No, it's minus 1 by root 2, but negative sign makes 1 by root 2. 1 by root 2 by 3 minus this will be a plus of 1 by root 2. Okay, and minus this will be minus 1 by 3 and plus 1. Yeah, now this all will be 1 by 2. This will be 1 by 3 root 2, so 4 by 3 root 2 minus 2 by 3. Yeah, so that will be 2 by 3 root 2 minus 1 by 3 as our answer. And we can just take LCM, so root 2 minus 1 by 3 as our answer. Yeah, let's go to the next one. This one is sine of root x dx. I can just let y equals to root x, and then y square will be x, and then 2y dy equals to dx. Yeah, so we have 0 to pi by 2. This is sine y times 2y dy. Now we can use integration by parts. So 2 times integral from 0 to pi by 2 sine y dy. Okay, so it's 2 times y minus cos y minus integral of 1 times minus cos y dy. Okay, then we have 2 times minus y cos y plus sine y from 0 to pi by 2. Yeah. Okay, now let's evaluate this. It's 0 plus 1 minus 0 plus 0, so that's just 2 is the answer. Yep, next one. Yeah, for this one we'll surely use beta gamma function. So it's beta of 3 plus 1 4 by 2, that's 2 comma 1 by 2 by 2. So that is gamma 2 gamma 1 by 2 by 2 times gamma 5 by 2. So gamma 2 is 1 times gamma 1 by 2 by 2 into 3 by 2 into 1 by 2 into gamma 1 by 2. So gamma 1 by 2 cancels out, 2 to cancel out, so this is 2 by 3 as the answer. Let's go to the next one. For this one, we can just let y equals to x square, and that does the thing. Dy by root under 1 minus x square. So it's just sine inverse x. Sine inverse, sorry, 1 minus y square, not x square. It's 1 minus y square. So it's sine inverse y, but y is just x square, so sine inverse x square plus c. The next one. For this one, we can again let sine inverse x as y, and then we get 0 to pi by 2, x will be sine y, and this will be y dy. And we just did this earlier, integral of sine y times y. Yeah, so what was it? I guess we did it here. Integral of sine y times y dy from 0 to pi by 2 is just 1. Yeah, we can use that here. Yeah, it's just 1, so that's 1. No need to do it again. Now for this one, we see that this is d sec x, and here we have dx square. So that's just integral dx square sec x plus x square times d sec x. So you can see that it's in the form of product rule. So that's dx square sec x, and x square sec x is the answer, plus c. Yeah. And for this next one, we can just with this one, we can, I guess, we need to use integration by parts, so that we can get its integral. So it's x, and the integral of this thing is tan square x by 2, and minus integral of 1 times tan square x by 2 dx. Now we can again change tan square x into sec, which is sec square. So x times x by 2 times tan square x minus 1 by 2. So this will be sec square x minus 1 dx. And so x tan square x by 2 minus 1 by 2 tan x minus x plus c. So I guess this is the solution. Or is it? I can modify this. We can just take x by 2 common, so that we have tan square x plus 1 here, and then minus 1 by 2 tan x plus c. So this will be x by 2 sec square x minus tan x by 2 plus c. Yeah, and we 1 by 2 common, and x square x minus x by 2 plus c. That's the answer. So we are at the end of the 60 integrals. You can see here we have done 60 integrals, and these were easy ones. Check the other videos in the playlist for medium and hard level integrals from Integral B, Nepal. Thanks for watching.